This is MATHguide.com, and my name is Mark Karadimos. Greetings. In this video, we're going to talk about what a normal distribution is. And to talk about it and to make sure you understand it, we're going to look at a bell curve, we're going to discuss standard deviation, and we're going to talk about the 68, 95, 99 rule. Let's get started. Let's talk about what a normal distribution is. In order to really hit this thing home, imagine this situation. Let's say you're part of an alien civilization that comes to Earth and you're examining all the different creatures on Earth and all the different items that you'd find. If you were to only study NBA players, NBA males, you'd think, wow, humans have a certain height. Looks pretty tall to the rest of us. But you'd have an idea that humans were pretty tall by our standard. Likewise, if an alien civilization came and they only happened to find children, young children, you'd think, wow, humans are very small. So it depends on which population you study, depends on what picture you'd have of our general population. So if you were to look at most people and you were to go to a city and you start looking at all the different people and start measuring their heights, you'd say, wow, maybe there's a random distribution of heights. Maybe the height is random. And at first it would appear that way. If you were to walk around and measure people's heights, even if you just measured all males' heights, you'd say, wow, maybe there's a random distribution. However, if you were to really look at all the heights and calculate or at least determine all the heights for many people, you'd start to see a pattern. Okay, and the pattern is that males have a tendency to hover around a certain average, okay, or a mean, right? There's a certain mean height for all males, and that height actually is dependent upon which country you go to. But let's say this alien civilization only goes to the United States. And if you were able to snap your fingers and measure the heights of all males, you'd probably find that the average height is somewhere around 69 inches. But you'd also find out that there are exceptions to that, and there are people who fall outside that. But you'd find that most males would tend to hover around that height. Now, if you were to dig a little deeper and start looking at the heights of females, you'd say, wow, the female half of the species of humans is shorter. So the average is somewhere around 63, 64 inches. And you'd say, that's interesting. And you'd also find out that the spread in heights for males is different than the spread in heights for females. Okay, so let's talk about that. So if you were to plot a graph of people's heights, you'd notice something. You'd notice that the mean, of course that's just the arithmetic average, arithmetic mean, the average, is right there smack dab in the middle. What does that represent? It represents the mathematical middle of all the data that you'd collect. You'd also notice that half of the people would be larger than the mean, half of the people would be less than or shorter than the mean if you're talking about heights. So right there in the middle, we're going to put the mean. So that means that human males, are around 69 inches when it comes to height. And what I'm going to do is talk about then what's the spread in the data. So how is it spread out? Now, when you talk about the spread, you have to talk about something called the standard deviation. So standard deviation tells you something about the spread. And when you make this bell curve, and that's what this normal distribution is sometimes called, because it does resemble a bell shape. When we create this bell shape or normal distribution, we mark what's called standard deviations that go from the mean. So right here, smack dab in the middle, we have the mean height for males, 69 inches, and then we have one standard deviation to the right, two standard deviations to the right, and then three standard deviations to the right. And then likewise on the left half of this normal distribution, we have 1 standard deviation left, 2 standard deviations left, and 3 standard deviations left. And let's say back in the 70s, actually, the CDC did a study on heights. We found that the standard deviation for male heights was around 2.8 inches. Okay, so what does that mean? That means I'm going to put in those standard deviations right now. Poof. And there you go. So you could see that I've put in all of those different heights for those different standard deviations. So to find the standard deviations, I took 69 plus 2.8. I got 71.8. I added another 2.8 and another 2.8. Likewise, to find all the other standard deviations, I started with 69 inches, then I subtracted 2.8, subtracted another 2.8, subtracted another 2.8. So this standard deviation of 2.8 is really telling you how far those gaps are placed apart in the table. So now you're thinking, okay, what's the significance of these gaps? Well, very significant. Now it turns out I need to talk to you about the 68, 95, 99 rule. So if you were to take a look at this distribution and you were to look 1 standard deviation left and 1 standard deviation right, and you were to just take a look at all the people that fell into that group, the people that fall into that group would almost be 70%. It turns out that that group right there would turn out to be about 68% of all your data. In this case, it would be heights. So more than half of the people are going to fall within a standard deviation right and left of whatever you're looking at. Okay, now let's say we went another standard deviation this way and another standard deviation this way. And we said, well, how much of our population would fall 2 standard deviations left and 2 standard deviations right? Well, that turns out to be 95%. Okay, so I'm going to put this down 95% so you can get this idea. So in other words, all of this data, okay, all of this data that we would measure, most of it would turn out to be 2 standard deviations left and 2 standard deviations right. All right, let's get rid of all this shading. All right, now let's talk about the last standard deviation. So that would be all the way over here, 3 standard deviations left and right. Well, that turns out to be 99%. Okay, that means most of the people that you'd measure, right, most of the people that you'd measure their heights, male heights, would fall between 60.6% to 77.4%. That is, sorry, not percent, 77.4 inches. That would be 99% of the male population in the United States. And that means 99% of the males you'd find would be anywhere between 5 feet 1 inches all the way to 6 feet 5 inches. Okay, that means you rarely see many people that are higher than 6 feet 5 inches. They're hard to find because that would mean less than 1% of the population is that tall. Likewise, if you go on the other end of the spectrum over here on the left, less than 1% of the population, less than 1 out of every 100 people you'd run into, 100 males that is, would be less than 5 feet 1 inches tall. So a bulk of the population falls within that variance, right? That's, I should say, that spread in height. So the only way you understand these problems is to take a look at an example. So given a mean of 22.4 and a standard deviation of 0.5, determine the 68%, 95%, and 99% intervals. Like, for instance, let's say we have a machine that dispenses coffee. And let's say the machine dispenses a cup of coffee on average that has 22.4 ounces. And what we want to do is figure out what does the spread in data look like And so in doing that, you could find the interval for the 68%, 95%, and 99%. Okay, and I'm going to talk about what that means. All right, first of all, what you do when you're given this problem, you put the mean right at the center of the bell curve. So I'm putting the 22.4. Okay, assuming it's ounces for coffee. All right, so it's 22.4. Now what we're going to do is we're going to put, or at least I'm going to put, all of these standard deviations. So I'm going to add 0.5 to the right. So that would be 22.9. And then I'm going to add another 0.5. That's going to be 23. Oops. 23, got ahead of myself. 23.4. And then add another, so that would be 23.9. All right, now we could also do the reverse. We could subtract 0.5 as we go to the left. So that would be 21 point, calculate, 9. Okay, then I subtract another half. I get 21.4. And subtract another, I'm going to get 20.9. All right, so there you go. This is what the spread looks like. Okay, now what does this mean? Well, let's answer the question and then we'll figure out what it means. So let's do the 68% interval. So when you go one standard deviation to the left, you get 21.9. When you go one standard deviation to the right, you get 22.9. That is the interval for, comma, that's the interval for the 68%. Now let's do it for the 95%. All right, well, I'm going to go 2 standard deviations to the left, so that would be 21.4. And then I'm going to go 2 standard deviations right, that would be 23.4. And there, that represents the interval for 95%. And then last, let's do the 99%. Okay, well, the 99% would be 3 standard deviations left and 3 standard deviations right. All right, so we now mechanically have done this. Now let's understand this. So if this is a machine that dispenses coffee, then you'd say that 68% of all the coffees that this coffee machine dispenses is going to be between 21.9 and 22.9 ounces. 95% of the coffees that this machine dispenses is going to be between 21.4 and 23.4 ounces. 99% of all the coffee that this machine dispenses is going to be between 20.9 and 23.9 ounces. So it gives you an idea how things are going to respond. Now, if you have a coffee machine, this is kind of important because you want to know how much you're delivering. You want to make sure you don't overflow the cup or underflow the cup. You want to make sure that you're delivering a responsible, a calculable amount of coffee to someone. And of course, if you don't care about coffee, then this could be about potato chips. It could be about anything, right? And it doesn't even have to be food related. But that's how people, when they're making items, they understand the spread in the data. All right. This has been a MATHguide instructional video, but I'd like you to go back to MATHguide. I'd like you to check out all of our hundreds of lessons, of our instructional videos, and interactive quizmasters. Take care. Hey, if there's a normal distribution, does that mean there's an abnormal distribution? No. No, it doesn't. No. Mm-mm.